Welcome to our YouTube channel, Experience Tutor. Today we'll discuss Wave Theory of Light Part 4, and today's topic is diffraction. This chapter is very important for the people who are giving 12th boards and preparing for IIT JEE, NEET, NAIMS and other engineering and medical entrance examination. So you can see this image. So what we can see is in the image that there are holes in a water tank, and and their width first has the more width, then the second has little less, and third one has very less width of that hole. Now we'll try to understand the wave pattern from these three images. So first of all, what is diffraction? Any bending of wave by means of other than reflection or refraction is called diffraction. Below figure shows the diffraction of straight water waves through various openings. When the openings is wide compared to the wavelength, the spreading effect is small. As the openings becomes narrower, the diffraction becomes more profound. The arcs of all kind of wave, including these occurs all kind. So there is a printing mistake. These occurs for all kind of waves, including the light waves. So now we'll study the topic diffraction of visible light. So can you see the image here? So in this image, in figure A and figure B, what we can see that there is a white window, and both places there is a source, light source, and in background there is a shadow falling in the screen. So diffraction occurs when light waves passes through any opening. That is the must condition for diffraction. Light casts a sharp shadow when it passes through an opening which is large compared to the wavelength of the light. That is figure 1. That is figure A, where opening is wide, the shadow is sharp. On the other hand, when the light passes through a small opening such as a narrow slit, it casts a fuzzier shadow. It is not a sharp shadow, it is a fuzzier shadow. So let us see what are the factors that affect diffraction. The first factor which affects diffraction is the extent. The extent of diffraction depends upon the relative size of the wavelength compared to the size of the obstruction that casts shadow. Long waves are better at filling in shadows. This is why foghorns emit low frequency, long wavelength sound waves. Likewise, the radio waves and standard AM broadcast bands. So now diffraction of radio and TV waves. So FM radio waves have shorter wavelengths than AM waves. So they don't diffract as much around buildings and aren't received as well as AM radio waves are in the mountain canyons. This is why many locations or many localities have poor FM reception while AM station comes in loud and clear. TV waves, which are also electromagnetic wave, behaves much like FM waves. Both FM and TV transmission are light of sight or line of sight, meaning the obstacles between the transmission towers and antenna for receiving TV broadcast can cause reception problems. So diffraction in microscope. So this is an example how diffraction takes place in microscope. So diffraction is not so helpful when we wish to see very small objects with microscopes. If the size of the object is same as that of the wavelength of light, the image of the object will be blurred by diffraction. If the object is smaller than the wavelength of light, no structure can be seen. This is why the bacteria you look at in a biology lab just appear as a small dots or rod. The internal details are too small to be seen with visible light. No amount of magnification can defest this fundamental diffraction limit. To see smaller details, you have to use shorter wavelength. A beam of electron has a wavelength associated with it that can be 1,000 times shorter than the wavelength of visible light. Microscopes that use beams of electron to illuminate tiny things are called electron microscopes. Because of the shorter wavelength used, the diffraction limit of an electron microscope is much less than that of optical microscope. So let us see, this was the example for the microscope. Now diffraction and dolphins. So let us see how this phenomena. Smaller details can be better seen with better wavelength or with smaller wavelengths. This is cleverly employed by the dolphin in scanning its environment with high frequency sound, or it is called ultrasound. The echo of long wavelength sound give the dolphin an overall image of objects in its surrounding. To examine more details, the dolphin emits sounds of shorter wavelength. With this sound wave, skin, muscles, and fats are almost transparent to dolphins, but bones, teeth, and gas-filled cavities are clearly apparent. And this is the end of our lesson for diffraction. Hope you liked this video. Thank you very much for watching this video, and please share our channel and give a like sign to this video. Thank you very much.